Hey, it's Mrs. Mays, and we're going to do some equilibrium problems today. This is practice problem 2, problems involving pressure, except this problem doesn't involve pressure. So I don't know why it's in this section, but we're going to do it anyway. And I'm pretty sure that's not the one I had set up first. Oh, right, because it said practice problem number 1. Sorry for the delay. Let me find that. Practice problem number 1. Okay, let's give this one a try. I want to show you how we use the value of k to decide where to assign the x. Remember, we're using the small x assumption here, so we want to assign x in such a way that it's going to be the smallest thing in our rice table. All right, so let's see first of all, what do we even have to start with? 0.1 moles of ClO, 1 mole of O2, and 1 times 10 to the minus 2 moles of Cl2, all mixed together in a 4-liter container. So let's evaluate the concentration of each thing first before we go any further. So if I have 0.1 moles in a 4-liter container, then that gives me a 0.025 molar concentration of chlorine monoxide. The concentration of oxygen is easier to calculate. 1 mole in a 4-liter container gives us 0.25 molar. And then finally, the chlorine gas concentration is 1 times 10 to the minus 2 moles in 4 liters, so that's 0.0025 molar. Okay, so now we know the concentration of everything. We're going to put that into our rice table. Oh, and the question says, what are the equilibrium concentrations? I knew that. So let's make a rice table. Alright, so the reaction is 2 chlorine monoxides produces 1 chlorine molecule and 1 oxygen molecule. And let's go back to the amounts that they gave us. Let's see, this one was 0.025 to start with, 0.0025, and 0.25. Again, we want to use the small x assumption, so x has to be the smallest thing in our rice table. What do you think is going to end up being the smallest? K is really small, so we're not going to make very much products at all. And the smallest thing I have right now is chlorine, right? So as we continue to make more products in the reaction, we're still not going to get very much. I think chlorine is still going to be the smallest thing that we have at equilibrium, because we're not going to make very much of it, and it's already our smallest thing. So that means if I have negative 0.0025 plus x for my change, then I'm going to use up all my chlorine and gain, well, just a little bit. Right? Like that's how I add initial plus change to make equilibrium, is by adding the initial plus a negative 0.0025 plus x. That gives me x. And because it's 1-to-1 mole ratio, then that means I have a negative 0.0025 plus x for my oxygen, and over here I have to double it. And I have to change the sign, because whatever I lose from my reactants, I gain from my products. So I'm going to double a negative 0.0025 plus x. Okay, so let me switch colors so I know what I'm doing. So that's a negative 2 times a negative 0.025. That's Okay, 2 times 25 is 50, so 0.0050 minus 2x. Okay, and then I combine these two together and I get 0.020 minus 2x as my equilibrium concentration of ClO. X is Cl2, and then combine like terms here, so I get 0.2475 plus X for equilibrium of oxygen. All right, my equilibrium expression, Kc, says that I've got, let's see, concentration of the products on top, and the concentration of my reactant is going to be squared because it has a coefficient of 2. And that is equal to 6.4 times 10 to the negative 3. It's also equal to, let's put our equilibrium values in, x times 0.2475 plus x all over the quantity 0.020 minus 2x squared. And since I have a small value of k, I can use the small x assumption. So when I use the small x assumption, that means essentially this value, it doesn't matter, and this value doesn't matter, because if I add a really small number to what I already have, it's not going to change the value that I have by very much. So that simplifies then. 6.4 times 10 to the minus 3 is equal to 0.2475x divided by, what's 0.02 squared? 4 decimal places, so it's 4 times 10 to the minus 4. Then I just solve for x. So multiply across and then divide by 0.2475. That gives me x is equal to 1.03 times 10 to the minus 5. So did we answer the question that they asked? Nope, not quite. But we're on our way. So let's wrap it up. The equilibrium concentration for everything is as follows. ClO is going to be 0.020 minus 2 times x. So with the sig figs that we're allowed, that's 0.020 basically, right? And then the concentration of chlorine is equal to x, so that's 1.03 times 10 to the minus 5 molar. And then I also get the concentration of oxygen, which is 0.00, it's 0.2475 plus x. And is that going to make a difference? No, it's not. So it's 0.2475 molar. There's our equilibrium concentrations of all the values. Now what if we had used the solver? Let's give that a try. Okay, if we were going to use our solver to figure out the value of x, then I have to rearrange things so that I have 0 on one side. That means multiply the denominator across. Don't forget that this quantity is squared, and then subtract across everything else so that I'm left with 0 on the other side of the equation. 2475 plus x, and that's equal to 0. So now let's bring up our calculator, and it's on B for me. There's our solver. Let's clear out what was there, and we'll type it in. 6.4 times 10 to the minus 3 times the quantity, give me parentheses, 0.02 minus 2x, close that parentheses and square that quantity, and then subtract across the rest. So I had x times 0.2475 minus, plus x. Close that out. And then I have 0 on the other side. And for our assumption for x, let's use something really small like 0.001. And then we do alpha solve. I expect to get the same thing here as what we had before with the small x assumption. And indeed I do, 0.032. So using the solver, I get x is equal to 1.03 molar. And I'm not going to go back through and show how to get the concentration of each thing, because all you do is plug that number in for the place of x. But the point is, you can use the small x assumption, or you can use the solver. You'll get to the same place in the end. Okay, now we have room for this practice problem number 2 that I showed you before. It's the same reaction, only this time we've flipped it around. Okay, so how might I change the way I assign the value of the equilibrium now? In this rice table, x still represents the smallest quantity on the rice table. So when I write my rice table this time and assign where x is going to be, I'm going to pick the thing that's going to be the smallest. So let's write our reaction first. And the initial was, let's see, the same conditions as before, right? 0.1, ClO1, yeah, everything's the same as it was before. So let me come back to my cheat sheet so I can see what we had. 0.0025 molar concentration of chlorine, 0.25 molar oxygen, and 0.025 ClO. Since everything's the same, my designation of the smallest value is going to be the same. Chlorine is the smallest thing. Now my reaction proceeds forwards, which means I'm using up the reactant. Chlorine is getting used up. So it's still going to work out the same way. This is going to be my smallest thing, and I'm going to assign x the same way that I did before. So 0.0025 plus x, yep, that gives me x. And I have 1-to-1 stoichiometry with oxygen, but over here I have to double it and change the sign, because what I lose from one side I gain on the other. So I'm going to make it the opposite sign. And that's going to work out to be 0.005 minus 2x. Yep. Okay. So I get x here, and I have 0.2475 plus x, and over here I have 0.020 minus 2x. And my k is products over reactants. This time it's the reverse reaction, so I have to take the inverse of my equilibrium expression. Just flip it over. Turn that fraction upside down. Okay, so I have 0.020 minus 2x is squared on the top, and that's being divided by x times 0.2475 plus x, which is equal to 156, which is the reciprocal of the equilibrium value we saw before, 6.4 times 10 to the minus 3, because it's the reverse reaction. Gotta flip things over, right? Okay, small x assumption works like this. If I'm adding or subtracting a really small number from some other number, then I can essentially say this is so small that it's not going to make a difference. Same here. It works only for adding and subtracting, not for multiplying or dividing by x. Now I have 156 is equal to 0.020 squared divided by x times 0.2475. Solving for x is a lot easier this time. Multiply this across, divide by 156, and this gives me an x that's equal to 6.475 times 10 to the minus 7. And that is indeed a very small value for x. I can say with confidence that it is less than 5% of our initial value, so a small x assumption is a valid assumption to make here. If we use the solver, then we would get the same value. So if you want to try this with your solver instead, go to Math and use your solver, and you should get the same number that I did using the small x assumption. So even though this wasn't a pressure problem, I wanted to work it out so you could see where to put x so that it can be the smallest thing in your rice table. All right, we'll practice more in class. See you guys.